sequences in series, this time with geometric sequences. These are our terms, but we're not going to use the sum because we're finding terms, and we're not going to use difference because we're going to find common geometric ratio sequences. So it's a multiplication each time. 1 times 5, 5 times 5 is 25, 5 25 is 125, and so on. We can also go down, halving in this case. In practice, the multiplication factor is usually quite little. So typically, it might be 5% interest. That will give a multiplier of 1.05 because you're adding 5% onto 100%. Or you might be losing value. If you're losing 20% a year, the multiplier is 80%, 0.8. At achieved level, the multiplying value, the R, will always be given to you, so you don't need to worry about that. And the formula we use is this. That gives us the value of the term, Tn, in terms of the starting value A, the ratio, and the position along it. Let's do one in practice. So we're asked the 12th term in that sequence. That's how we calculate it. We're asked the term, so we're using the T formula. Our start value A is 80. Each value is 1.5 times the one before, so it's 1.5, and we're asked for 12 along. Stick it in the calculator. Be quite careful to keep the -1 raised to the ratio, and we get quite a large value. That large value, incidentally, is why the ratios are usually quite small, because otherwise you get massive numbers. Here's one in word form. We have an investment, and we're going to keep it for 15 years. This is how we calculate it, and the mental process is we looked at how much it is. We're not asked for a total over time, just how much at a specific point in time. Therefore, it is a term, not a sum. Starts at 2000, it's going up at 4%, and that'll be given to you. And then the tricky bit is n is 16, and the reason for that is the difference between how we count in the real world and how we count in sequences. In the real world, this would be at 0 years, but sequences always count from the first one. So 0 years is n is equal to 1. If 0 years is n is 1, then 15 years is n is 16. At achieved level, they will never ever do anything to fool you like that. Well, you do have to be quite careful at the higher levels. So we stick that in our calculator and we get the answer. Process can be done in reverse. Same formula. So here's an example. We're losing 40%. How long does it fall to a price? Well, in this case, it's solved like this, and the process to go through is we're asked when is the value, and it's a value, not a sum, 500. If it starts at 5,000, that's our A. It's losing 40%, so the multiplier is 0.6, and again that will be given to you. And n is our unknown. How long? That's what we're trying to find out. At this point, unless you can do logs, you're going to have to either guess and check it or stick it in the solver. I'm going to show it, but it's not important. And the answer is 4.5 years. So we use this formula when we have a sequence of multiplications, and we know it's a multiplication because there's R in the formula, not D. We want to find the value of a point along, or we want to find where a point along gets to a specific value.